So before going to this symmetrical T attenuator, first we'll see what do you mean by attenuator. So an attenuator, it is defined as a network. It is capable of producing a desired reduction in a signal level. Okay. So when this circuit is used in between generator, source and load, the main uh, functionality of this attenuator is it is the network which is capable of producing a desired reduction in a signal level. Right? So generally these attenuators are connected in between the source and the load, or simply it is also called as a source, it is also called as a generator and load. Yeah, the simple right. So can anybody answer? So what kind of circuitry do you imagine it? Attenuator means, so attenuator, it is nothing but it is a made up of simple resistive elements. Attenuators are made up of simply a resistive elements. See here. So this simple circuit, it will work as a attenuator. Can anybody classify what kind of attenuator is this? Is it symmetrical or asymmetrical? The first nano. Hello. చెప్పండి ఆన్సర్ చెప్పండి. ఇది సిమెట్రికలా ఎసిమెట్రికలా? Hello.
Symmetrical, sir.
It is a
Symmetrical, sir.
Symmetrical network. Okay. Here, if you see here in the series arm, it is both are same. RA, RA. Series branch elements are same. RA and RA. Okay. So it is a symmetrical attenuator. And is it a T-type attenuator or a Pi-type attenuator?
T-type.
T-type attenuator. Right. Now, to derive these series branch element and element R. So for this circuit, just we source source ES insists with a source resistance of R, and similarly this simple attenuator with a resistance, right? Resistance the resistance R. It is terminated with the resistance R, and it is connected with the source with the source of EG, or it is also can call it as VS. See here, it is terminated with R. Okay, and we also know that for a symmetrical network, the input impedance, it is equal to the terminating impedance. Means it is also called as a characteristic impedance. So whereas in case of these attenuators, the characteristic impedance, that is denoted by Z0, or it is also denoted by R. It is the Z0 or R0 equal to R. Right. Now for this circuit, it is terminated with the R, and it is connected with the input side, that is source side, with a input source value of EG and series resistance of R. Right. Now in this first branch, the current flowing through this branch, it is denoted by IS, and in this branch, the current flowing through this branch, it is denoted by IR. Now if you apply for this one, if you apply a KVL, so here we are trying to find out the ratio of IS by IR. So to get this IS by IR ratio, simply you apply here KVL to the output loop. Yeah, just hold on. Yeah, okay. So it is transmitted by the resistance R, and it is also connected with the source voltage of EG. Now, if you apply KVL in this second loop, it is transmitted with the R, right? And the current flowing through this branch is called as IR. Now, if you apply KVL here, by applying KVL, right? Mesh 2. Can anybody read out this mesh equation now? This is RA plus R, okay? RA plus R, okay? This you can read as RA plus R into IR plus here. So here in this first branch, first mesh, the current flowing in this mesh is IS, right? So here IS and IR in the opposite direction, right? Plus R is equal. Also, we can write like this also, right? Now, if you simplify this one, if you rearrange this equation, you will get this one. If you get all on one side, RB, ISRB, right? So this is RB of IR minus IB, right? So if you get it on the LHS side, you will get I is remaining all are IR terms, right? So if you simplify this one, you will get ISRB is equal to RB R. Yeah, right? Now, so here we got this IS by IR. IS by IR. IS by IR is nothing but the capital N. Right? So therefore, IS by IR equal to RA plus RB plus R divided by RB. Now, this IS by IR is nothing but the capital N. Okay. Now, similarly, for a symmetrical network, the characteristic impedance, it is denoted by Z0 is equal to R0 equal to capital R. For this attenuator, it is denoted by capital R. Therefore, capital R, there is nothing but the input impedance. So it is called as the, so if you see it from the input side, from this side, how it looks like the circuit, this RA, this side, source side, input side RA, it is series with the parallel combination of this RA plus R and RB. Yes, is it clear? జస్ట్ చూడలేను ఇది కొంచెం లోడ్ అవుతా ఉంది ఇది ఓకే చూడండి దీంట్లో ఏం లేదు సింపుల్గా మనం దీనికి ఈ లూకి ఈ మెష్కి కేవీఎల్ రాసాం దాన్ని రీఅరేంజ్ చేసాం అండ్ వీఆర్ ట్రైంగ్ టు ఫైండ్ అవుట్ దిస్ రేషియో ఇన్ టర్మ్స్ ఐఎస్ బై ఐఆర్ ఫామ్లో తీసుకొచ్చాం దిస్ ఐఎస్ బై ఐఆర్ బట్టి క్యాపిటల్ ఎన్ ఓకే సో ఇది ఒక ఈక్వేషన్ వచ్చేసింది ఐఎస్ బై ఐఆర్ ఓకే దీన్ని క్యాపిటల్ ఎన్తో డినోట్ చేసాం నెక్స్ట్ ఏంటిది దీనికి ఇన్పుట్ ఇంపిడెన్స్ ఫైండ్ అవుట్ ఫుల్ రెసిస్టర్ నెట్వర్క్ సో ఇన్పుట్ ఇంపిడెన్స్ ఎలా ఫైండ్ అవుట్ చేస్తాం సో ఇన్పుట్ ఇంపిడెన్స్ ఇస్ నథింగ్ బట్ ది క్యారెక్టరిస్టిక్ ఇంపిడెన్స్ సిమెట్రికల్ నెట్వర్క్ ఇన్పుట్ ఇంపిడెన్స్ అంటే ఏంటి క్యారెక్టరిస్టిక్ ఇంపిడెన్స్ ఎందుకు క్యారెక్టరిస్టిక్ ఇంపిడెన్స్ అంటాం ఎందుకంటే దిస్ సిమెట్రికల్ నెట్వర్క్ ఇట్ ఈస్ టెర్మినేటెడ్ విత్ ద ఆర్ ఓకే సో ఇక్కడ ఇన్పుట్ ఇంపిడెన్స్ కూడా జెడ్ ఆర్ జెడ్ నాట్ ఈక్వల్ టు క్యాపిటల్ ఆర్ ఓకే ఇప్పుడు దీనికి ఇన్పుట్ ఇంపిడెన్స్ ఎలా ఫైండ్ అవుట్ చేస్తాం సో ఇఫ్ యూ సీన్ ఫ్రమ్ దిస్ సైడ్ ఇన్పుట్ సైడ్ నుంచి చూస్తే ఈ నెట్వర్క్ ఎలా ఉంది మనకి ఈ ఆర్ఏ, ఈ ఇన్పుట్ అంటే ఆర్ఏ అనేది సిరీస్ కాంబినేషన్లో దీనికి ఉంది. ఇవి ఎలా ఉన్నాయి? ఆర్ఏ ప్లస్ ఆర్టీ ఈ రెండు సిరీస్లో ఉన్నాయి. ఈ రెండు సిరీస్ మళ్ళీ దీనికి ప్యారలల్ ఉన్నాయి. అంటే దీన్ని సింపుల్గా రాయొచ్చు ఆర్ఏ ప్లస్ R1 R2. ఇక్కడ చూడండి, ఆర్ఏ ప్లస్ ఆర్ ఇంటూ డివైడెడ్ బై టోటల్ రెసిస్టెన్స్, దట్ ఈస్ ఆర్ఏ ప్లస్ ఆర్బి ప్లస్ ఆర్. రైట్? ఓకేనా? క్లియర్ అమ్మది? ఇది చూడండి, ఇన్పుట్ ఇంపిడెన్స్ అంటే జెడ్ డినోట్ చేశాం. ఇక్కడ జెడ్ ఇన్ నెట్వర్క్ కాబట్టి ఈ ఇన్పుట్ ఇంపిడెన్స్ ని ఇట్ ఈస్ క్యాపిటల్ ఆర్. క్యాపిటల్ ఆర్ ఈక్వల్ టు ఇక్కడ చూడండి, ఈ ఆర్ఏ అనేది ఇట్ ఈస్ సిరీస్ దీనికి ఈ మొత్తం నెట్వర్క్ కి. ఇది ఎలా ఉంది? ఈ దీస్ ఆర్ఏ ఆర్ దీస్ ఆర్ సిరీస్ అండ్ ఈ రెండు ప్యారలల్ ఉన్నాయి. అది ఏమైనా ఆర్ఏ ప్లస్ ఆర్ ఇంటూ ఆర్బి డివైడెడ్ బై టోటల్ రెసిస్టెన్స్. చూడండి, ఆర్ఏ ప్లస్ ఆర్ ఇలా. సో ఇఫ్ యూ డివైడ్ దిస్ డినామినేటర్ బై ఆర్బి, చూడండి దీన్ని డివైడ్ చేస్తే ఈ ఆర్బి క్యాన్సిల్ అవుతుంది, ఇది మొత్తం ఆర్బి అవుతుంది. సో ఇప్పుడు ఏమవుతుంది? దిస్ ఆర్బి ప్లస్ ఆర్బి ఇది నథింగ్. డినామినేటర్ మొత్తం this equation will get it is ఇది చూడండి, ఇది ఏమైంది ఇప్పుడు? ఇది దిస్ we can write it as capital R equal to RA plus R divided by N. Now if you take calcium, then calcium తీసుకుంటే ఏమవుతుంది చూడండి. ఓకే, Rn is equal to N into RA, right? N into RA plus R. Right? Now if you rearrange this equation, n terms of adjustment here. So R terms of adjustment, R of n minus 1 is equal to RA of n plus 1. Therefore RA equal to R into n minus 1 by n plus 1. Similarly, now see here, now if you substitute this in this equation, if you substitute this RA value here, so we have this equation, right? N equal to RA plus RB by R divided by RB. Now in this equation, so if you replace this, substitute this RA value, you will get the RB in terms of R and N. Just hold on, ఇది లోడ్ అవుతున్నాం. ఇది okay, is it clear? Is it clear? Now we got this series branch element value, that is RA value and RB, both in terms of, we got in terms of R and N, in terms of R and N values. RA, we got it as RA equal to N minus R into N minus 1 by N plus 1, and RB equal to R 2N by 2 by N square minus 1. Yeah. So my whole derivation I am doing here. So simply this no, find this and on this of character and so this value this question are value. So we are dealing with it is symmetrical for a symmetrical put in that means the done. So this card did not, but here is denoted by capital R. So for this capital is not equal to the run through this run through this divided by now there is but this this are the instance now find out the ratio of is by okay now by applying and okay it is current emission so both yes is zero. Now if you simplify this equation all IR terms are plus equal to S3. Therefore yes RA plus D plus G and S by R I equal to plus RB R. Just go to Yeah, close. కనపడుతుంది. Is it visible? Hello.
Yes, sir, now visible.
చూడండి. Now, if we rearrange this equation, IS by IR, we'll get this in terms of RA plus RE plus R divided by RB. Yeah, IS RB plus R divided by IS by IR equal to RE plus RB plus R divided by R. దీన్ని రీఅరేంజ్ చేశాను అంతే. రైట్. నౌ నెక్స్ట్ now if you find out this input impedance, that is Zin. Input impedance Zin equal to capital R. So how will you find out input impedance? Input impedance is nothing but the, so if you look at from this side, okay, you choose along with this RA. In mesh 1 లో ఉన్న RA, RA is series with parallel combination of these all, that is RB to RA plus R divided by total resistance, that is RA RB plus R, the total resistance. Right. Now if you rearrange this equation, then rearrange చేస్తే capital R equal to RA plus capital R equal to RA plus RB into RA plus R divided by total RA, RB plus R. Okay. Now, if you divide this numerator and denominator by RB, both numerator and denominator by RB, this RB get cancelled. Okay. Now, if you rewrite this equation, this looks like RA plus okay, RA plus RA plus RA plus R divided by RA RB plus R divided by RB, right? Therefore, yeah, so this we can write it as RA plus RA plus R divided by C1. This total term, this we can write it as capital N. Yes, is clear? So capital N, the capital N is nothing but the IS by IR is equal to IS by IR equal to RA plus RB by R, RA plus RB plus R divided by RB. Right? So this total we can replace with N. Right? So this is equal to capital R. But now if you take LCM, okay, this you can write as N into capital R, and if you take LCM and if you cross multiply, N into R into N into RA plus RA plus R. Right? Now, if you rearrange this equation, here RA terms on one side and capital R on one side, this will get NR minus R is equal to N into RA plus RA. So therefore, if you take RA common, this we can write it as RA of N plus 1 and R of N minus 1. Okay. So we want this RA. Okay. So therefore, RA equal to R into N minus 1 divided by N plus 1. Right. So we got series branch value RA in terms of terminating impedance and capital N. Okay. This is equation 1. Now, similarly,